Hey everybody. Today we're talking about discrete random variables and discrete probability distributions. So a discrete probability distribution is just a list of all the possible outcomes of a discrete random variable, along with the probabilities of each outcome. For instance, if we have a random variable x that represents the number of windows in a randomly chosen room of a large house, we might have this distribution. So here we have a house with 16 rooms, and we have between 0 and 4 windows in those rooms. We have 3 rooms with 0 windows, 5 rooms with 1 window, and so on. The notation here is a little bit odd, but is actually completely normal in probability theory. The uppercase x represents the random variable itself, whereas lowercase x's, like x1, x2, x3, x4, represent the individual values. So when you see little x sub I, it's representing an individual value. Two important facts here. First of all the probabilities have to sum up to 1. To say this in words, when you do a probability experiment, something has to happen. So with probability 1. A bit more mathematically, we write sigma probability x equals xi equals 1. When I see that sigma in the context of college statistics, I'm always just reading it as add them all up. So that notation means add up all the probabilities for the individual values of the random variable x. And you should get 1. The second property that's important here is that since outcomes are disjoint, probabilities can be added in a discrete probability distribution. A bit more mathematically, p x equals xi or xj is p that x equals xi plus p that x equals xj. So to get the probability of one outcome or the other, you take the individual probabilities and you add them. Here's an example using that same distribution we were looking at a minute ago. Let's find the probability that x is greater than or equal to 3. We're going to do that by taking the probability that x is 3 and the probability that x is 4, adding them up. So we're doing 2/16 plus 1/16 to get 3/16. Secondly, we can do the probability that x is even. So here we're taking the probability that x is 0, 2, or 4, adding up those 3 individual probabilities, 3, 5, and 1/16 respectively. We add them up, we get 9/16. One more example. We want to fill in the missing probability for this discrete random variable y, and in this discrete probability distribution. And this is a good place to pause the video and try to figure this out on your own before seeing my explanation. So all the probabilities have to add up to 1. So what I'm going to do is I'm going to take 1 and subtract off the 4 probabilities that I already have. And so 1 minus 0.04, minus 0.12, etc. gives me 0.21. So if I fill that in for the question mark, all those probabilities now add up to 1. So the question mark should be 21%. By the way, notice that I used the letter y here instead of x. There's nothing special about the letter x for a random variable, so just be aware of that. One final example. Find the probability that y is less than 200 in this same discrete probability distribution. So again, pause the video, try and work this out on your own. So we could do this just by adding up the individual probabilities that y is 5, 10, 25, and 50. That works just fine. But in this case, there's a slightly quicker way using the rule of complements. The event that y is less than 200 is complementary to the event that y is equal to 200, in the sense that if one happens, the other does not. So we can compute the probability that y is less than 200 by doing 1 minus the probability that y is equal to 200. 1 minus 0.21, 0.79. The probability that y is less than 200 is 79%.